All right, another technology sprint here at Accelerate 2023, brought to you by those wonderful people at Fluke Reliability. Great place. Reach out to them. Go out to the internet and find out more about Fluke Reliability. All right. We're meeting with Sabrina right here. Sabrina right here. We're going to be talking about that tech right there. Give us a little 411 on what that tech is all about there, Sabrina.
All right, so this is actually a demo one. This is not the real one. The real one is a little bit more sturdy and not made out of plastic.
It's all fine. It's all fine. It does communicate what it does. Talk to us.
So this is called the Paraline. It's a tool for measuring parallelism in roll-to-roll transfer processes, like, for example, pulp and paper machines, corrugators, or blown film.
The rolling thing.
Yeah, so
okay, gotcha.
all of these machines, all of these materials go through a roll-to-roll transfer process. This is used to measure the parallelism between those rolls, because having those rolls misaligned will lead to product defects, early machine wear, and unplanned downtime, because if that machine breaks down, then how are you going to make your money?
So what's the process? So I've got these lights, got all this fun stuff. Take us through that.
So the real one, you can't see it, but these three pucks, they look like hockey pucks.
Yep, they're pucks.
They represent the gyroscopes that are inside of the real device. And you can see they're all facing different directions.
Yep.
It's one for the roll, one for the yaw, and one for the pitch.
There it is. Okay.
And those are used, they're the same gyroscopes that are used in fighter jet planes.
And so the benefit of a solution like this is to ensure that the rolls are properly aligned.
Exactly, they're perfectly parallel, because you can imagine.
Perfectly parallel.
You can imagine you have two rolls and you have material going through it.
Yes.
And they're like this, you're going to have more tension on one side than the other.
And it doesn't take much.
It really doesn't.
It doesn't. So
we're talking about aligning things to the distance of a human hair.
No way, really?
Yes.
And as you continue to refine that alignment, the greater likelihood of, well, the life expectancy of that asset, the material loss as a result of out of alignment.
Correct.
You just get that asset uptime more and more. Okay.
Exactly. So you're prolonging the asset life.
Yeah.
You are getting a better product quality.
Yes.
You can run the machine faster.
Yes.
So that you can produce more product.
Have you seen them manufacture toilet paper?
I have.
It's insane.
Yes.
The speed, and it's toilet paper. It's a speed. It's like, okay, there you go.
So this roll, how it works, usually they used to use pie tapes or dial indicators or even theodolite, which they work, but some of them you just can't have the same precision, and also that error accumulates as you go down the line, since you're comparing things next to each other. Right? So let's say you align something 2,000 of an inch from each other, and then 2,000s, that error can accumulate. At the end of the line, you have an eighth of an inch in misalignment, which can really create issues. This device right here, first of all, it's super simple to use. It does not require a line of sight, and distance doesn't matter. It's not going to affect it. It's going to have the same accuracy whether a roll is 5 feet away or if it's 200 feet away. So the way it works, you can grab it.
I will. I want to grab it.
This is just our prototype.
It is.
You grab it in both hands.
Okay.
Okay. You have a roll. You put the feet on the roll and you rotate it on the roll.
Oh, like this? Like I'm doing this?
Exactly.
I
wish the video was on.
That's okay, but we got a nice sunset there.
So you rotate it across the surface of the roll, and it will input right away compared to your reference roll.
Right.
What the offset is. And the reporting is also instantaneous and easy to read, so we can tell the mechanics right away what they need to do to fix the machine.
I like it, Sabrina.
Yeah, it's cool.
You're making life better for industry as a whole, right here, right now. How do they get a hold of you? If they're saying, hey, I'm interested in this thing and I want to know more about it, how do they get a hold of you?
You can call me.
Call you? Or email you, or
you can email me, you can call me, you can message me on LinkedIn.
Yeah.
My name is Sabrina Jastram.
Right there. Solutions right there, with colorful lights. Here at Accelerate 2023, brought to you by Fluke Reliability. Cool company, great people, solving problems. We're going to have more coming from this particular event, so stay tuned.
You're listening to the Industrial Talk Podcast Network.